Alrighty. So I think the topic today is percent composition and why chemists are so excited about percent composition.
Yes, it is.
I'm pretty sure that nobody else on the planet is excited about percent composition except for chemists. But maybe somebody is. But every textbook, every course has this chunk pretty early on where you're expected to do these calculations that it's never really clear why anybody would ever have wanted to do them. And so I wanted to have a conversation with you to say why these, to expound on why these percent compositions are so meaningful.
Yeah, definitely.
So I think I've got 2 or 3 answers to that one, or points to raise on this one. The first is, I think it goes back to when chemists were just getting their act together and actually doing something useful. If you have a lump of dirt and you can break it down into its constituent elements by, I don't know, burning it off or heating it up, or however you separate them out. When you do that, if you get consistent amounts of each element, then you have a very good idea that you've got a pure substance. You don't have a mixture. If when you do percent composition and you try to break down all of your elements and you're doing it for a mixture, well, a mixture has a certain amount of carbon and hydrogen here and a different amount of carbon and hydrogen here, and maybe some oxygen thrown in, and you've got this other compound up here in your pile of dirt that's carbon, nitrogen, hydrogen, sulfur, whatever it is. If you keep on doing percent composition throughout that mixture, you're going to keep on getting different percents of each element. And so if you're a chemist and you're trying to understand the world, if when you do percent composition, you always get 30% carbon, 15% hydrogen, and 16 or 20% or some specific number of percentage of oxygen, then you know that you most likely have a pure compound. And so that means that you have successfully, there's a good chance that you have successfully isolated a pure substance. And then now you've got this pure substance. Now maybe you can do something with it that you could predict. And I think that might be why chemists get so excited by percent composition.
Yeah, exactly. There's when you get that pure substance, and like I'm taking organic chemistry, that's like the #1 thing we're doing right now in our labs. Yeah. But also there's a lot of inquiry and exploration as well. When a chemist or a scientist finds a substance or material, they don't know what it is, or if they think they've made a new compound, they can figure out what elements make up the compound, how it's arranged, and all that meaty science that maybe we can't get too much into this course right now, but there's just a lot of science, and it's really exciting for chemists.
Yeah, and if I think by the time anybody watches this video in this course, they will have already watched the video where I talked to Dr. Hitchcock, and he talked about he needs his students to be able to do percent composition and to do limiting reagent calculations, but he specifically mentions that this is the type of thing that he and his students do, and he's an organic chemist, just as you mentioned.
Yep.
So that's why I think chemists are so excited about percent composition.
Yeah, I think it looks really tedious in the textbook, and I guess even if you're not a chemist, you probably use a lot of prescription medicine, over-the-counter medicine, and so that probably had some use in percent composition, so maybe that's something you can be thankful for at least, you know?
Yeah, good job being thankful. And if you're excited by this percent composition calculations, then you probably are a chemist, and you might not know it, but you're about to become one. It's probably something like that.
Yeah.
Do you think we should do 1% composition calculation I mean,
Um,
there's thousands on the internet. There's plenty in this course and other videos and in the text. Do you want to do one?
sure. I guess we should for doing it for its sake, you know.
Okay, because we're chemists and we're excited by it. Okay, all right. So I've got one here. So calcium chloride, CaCl2, is an ionic compound. Calcium ions bonded to chloride ions. One of the deals on this one is this is sometimes used in like driveway melts. So it's a salt. It's not the most common salt used for melting snow and ice on driveways and sidewalks and that sort of thing. The most common one would be sodium chloride, but sometimes calcium chloride is used. And so it's a driveway melting salt. And it's 1 calcium and 2 chlorines. And so the question might be something along the lines of, what is the percent composition of calcium chloride? Or maybe it'll ask, what's the percent of calcium in the calcium chloride? Or maybe it'll ask, what is the percent of chlorine in the calcium chloride? But it'll be something along those kind of lines. Okay.
Yep.
And so it's a percent. So we want to find out what kind of percent is it? Well, it's a mass percent. Almost always, it's a mass percent. So we want to find out what is the percentage of in one molecule, in 1 mole, in 100 moles, 1,000 moles of calcium chloride. What is the mass percent of calcium in that compound? What is the chlorine percent of calcium in that compound? And so I want to know the percent of calcium by mass in calcium chloride. Can you see that okay?
Yep.
Okay. So if I have 1 mole of calcium, and I would want to know what is the mass of calcium that I have in 1 mole of calcium chloride, right? So if I've got 1 mole so if I have 1 mole of calcium chloride, what's the mass of 1 mole of that calcium in there? And so I'm going to take that and I'm going to multiply it by 40 point. Oh, you know what? I've got the periodic table here. So let me just share the screen here just to remind people. And so here's calcium over here, and calcium has a mass of 40.078. And we're going to need chlorine later on, which is over here on the right. Here's chlorine that has a mass of 35.453. So we'll need those 2 numbers at some point. Okay?
Yep.
So it was 40.078 grams of calcium in 1 mole of calcium. Fair enough?
Yep.
And so that will tell us that in 1 mole of calcium, we've got 40.078 grams of calcium, which is great, but it doesn't tell me anything about the percentage, because I don't know what the mass of the whole calcium chloride is. So I've got to figure out the mass of the whole calcium chloride. So I'm going to say 1 mole of calcium chloride times, okay, so let's do a little math here. I know that I've got calcium times 1, and I've got chlorine times 2. Is that showing up? So this is 40.00778, sorry. And this is 35.453 times 2 equals 40.078 equals
70.906.
70.906. This is different than the way I did it in my notes. So if I add those 2 together, I get to 110.98 grams per mole for calcium chloride, right?
Correct.
So if I have 1 mole of calcium chloride, I'm going to box this off over here, times 110.984 grams of calcium chloride divided by 1 mole of calcium chloride. That's, I can multiply by 1 and divide by 1 in my head. So that's 110.984 grams of calcium chloride. So that tells me that I have 40 grams, basically 40 grams, 40.078 grams of calcium in my 110.984 grams of calcium chloride. So to get to the mass percent, I know that it's going to be 40.078 grams of calcium divided by 110.984 grams of calcium chloride times 100%. And that is 36.1115%. And then I was looking at this and I was thinking that maybe I've got 1, 2, 3, 4, 5, 6 digits here. And up here I've got 1, 2, 3, 4, 5 digits. So I probably need to round this to having only 5 significant digits. So I got 36.112% calcium in calcium chloride.
Awesome.
I was pretty happy with that.
What if we wanted to know the mass percent of the chlorine in the compound then?
Yeah, it's a great question. And I was thinking about this in terms of different things that we could work on. So we know that it's 36.112% calcium in chlorine. And in that video that I had a few days ago that you might have watched with Dr. Hitchcock, he said it was a good strategy to see if you can attack problems from different ways. And it occurred to me as I was working on this problem before, this is an excellent example of ways that we could attack it from different ways. One way to attack it would be to simply say, hey, this compound has calcium and chlorine, and 36.112% of it is calcium. So 100% minus 36.112% must be equal to the percent of chlorine. And so if I subtract 36 from 100, I get 63.888% of chlorine. So that's one way. So that's one way of solving this problem, and it's probably the simplest. And frankly, you probably got to get to the point of saying, hey, if it's 2 compounds and one of them's 36, then I'm subtracting to get to 63. Because if you do what I'm about to do, then it probably means that you saw this took like 3 seconds. What we're about to do is probably going to take another minute or 2.
Yeah.
But just bear in mind that we're pretty sure that the answer better be 63.888%. So let's do the chlorine, but do it the way that we just did it a few seconds ago. So I'm going to do the percent of chlorine in calcium chloride. And so this time I've got 2 chlorines. I've got 2 moles of chlorine at 35.453 grams per 1 mole of chlorine. Which is equal to, as we just said, what was it again, 70.907? 70.906 grams of chlorine in 1 mole of calcium chloride. And so then I'm going to take my 70.906 grams of chlorine, and I'm going to divide it by my 110.984 grams of calcium chloride, right? So this tells me this is my mass of chlorine inside my mass of calcium chloride. And it turns out that that is equal to 0.63888. And if I go 0.63888 times 100%, I get 63.888% of chlorine in calcium chloride.
And that's the exact same answer we got
Yeah.
from above.
Yeah, so that's really promising, really promising. So that's a couple of that's a way of doing a percent composition. And if I'm the first person to have ever made or found or calcium chloride, I'm thinking, oh my, I'm an amazing chemist. And if I make some other compound and I keep on, or think I made a compound and I keep on getting the consistent percent compositions, then I think, oh, I probably made a new compound. That's pretty exciting.
Yeah, percent composition is kind of fun.
Yeah. So is there anything else that we should say about this one, do you think, Kevin?
No, I don't think so. In this course, it doesn't play a huge major role, but it's going to be on the homework, so you might as well get a hang of it or understand it at least.
Yeah, well, and it took us 2 or 3 minutes to do this. Students in this course, if they're confronted with these questions, they need to be able to do them in 2 or 3 minutes. If it's taking you 6 or 7 minutes, you're going to run out of time and you're not going to be able to, you got to get to the point where you can do them fast.
Alrighty.
So thank you, Kevin.
Thank you, Dr. Hunter.
Okay. And I'll talk to you again later today.
Talk to you later.